It is time to move on to page 19 in your book. Page 19, you need a yellow, a blue, and a green again. So if you do not currently have those, we may need to pause the video and make sure everyone gets a yellow, a blue, and a green. So pause, get your colors. And let's do this. So last class on page 18, we talked about color coding moles. We talked about what a mole was on page 17 and 18. Remember, a mole is how we count atoms, molecules, other particles when there are an awful lot of them. So 1 mole is when you have 6.02 times 10 to the 23rd of something. That's basically 602 septillion of something. And if you weigh all those particles, pile them up and put them on a scale and weigh them, then that number of grams will be called what we call your molar mass. Conveniently, the molar mass is the same as the number of grams. The molar mass is the number of grams for that number of the average atomic mass on your periodic table. Very convenient. So keeping that in mind, here's what we're going to do. We're going to do some calculations of mole problems. And first, what we should do is we should color the problem with either our yellow, our blue, or our green. Remember that we're using this color coding system where yellow is grams, like golden grams, the cereal. And your number of grams is always a number from the periodic table. That is always equal to 1 mole specifically, and for moles we're going to use the color green. And 1 mole, remember, is when you have 6.02 times 10 to the 23rd of something, and we're going to stick, for this unit, we're going to stick to atoms. 6.02 times 10 to the 23rd atoms. Atoms are blue. When it's blue, use 6.02. It rhymes. 6.02, that's when you use blue. Okay, so we're going to color code the problems as well. So if I look at number 1 here, it says you have 4.6 moles of titanium. Well, moles is green, so I'm going to color it green. How much is the mass of your sample in grams? Grams are yellow, golden grams, so I'm going to color those yellow. Okay, color it, actually color it. Don't pretend you're coloring and not actually coloring, just frickin' do it. Alright, quit being so lazy. And what we do here for these problems is, if we look back at page 18 where we wrote some steps, it said start with your given number, unit, and element over 1. So the given is always whatever number they gave you. So they gave us 4.6 is our number, the unit was moles, that's like our color, and our element, titanium. 4.6 moles of titanium. Now we can abbreviate titanium, we can use the symbol from the periodic table. But the first thing we're going to do is rewrite 4.6 moles of titanium as a fraction over 1. Because that's what step 1 told us is to start with the given number, unit, element over 1. And we're going to color the moles here too. Just like that. Okay? Step 2 says figure out how many fractions and draw them. Well, I'm going to go ahead and tell you now. If you see the word moles, then that's going to be 2 fractions. I have the word moles in this problem. That means I need 2 fractions. We've already drawn 1 fraction, so just draw a second fraction. And these fractions are always going to be times each other, so put a times sign in between. Again, if you see the word moles, you're going to need 2 fractions. We had already drawn 1, so now we draw our second fraction. They're always times each other, put a times sign in between. And step 3 says your unknown, which should be a unit and an element, goes on top of the last fraction. So the unknown is basically whatever your other color is. So we had green moles. The other color we're using is this yellow grams. So I'm going to put grams on top of my last fraction. And we're still using titanium for this whole problem, so I'm going to label that titanium as well. And grams are always going to be yellow golden grams. Now, to finish filling out our fractions, we have another little rule we need to know, which is that what goes up must come down. I always say that. What goes up must come down. So basically, not the number, just the words, but look at your words that are on top of a fraction, and what goes up, those words that are up, they always have to come down. So I'm going to move those same words down to the bottom here. What goes up, not the number, just the words, what goes up must come down. Always move. Your unit and element should always move to the bottom. Not the number, just the unit and the element. What goes up must come down. Now we need numbers to go in our second fraction here. And we can look back at these shortcuts we had to fill out our fractions. We wrote that green should always be 1 mole. So if I've got green here, this is moles, and it should always be 1 mole. That's what we wrote on page 18. It should always be 1 mole. So I'm going to stick a 1 there. We also had a shortcut for what yellow was going to be. Yellow is always some number from the periodic table for grams. Well, conveniently, in this problem, we have already copied and pasted a screenshot for you of titanium from the periodic table and its number of grams. It's 47.90. So I'm going to take that 47.90. That's my number of grams that goes on top here. From here, all my fractions are filled in, and once all my fractions are filled in, I'm just going to multiply top times top, bottom times bottom, get a new top and a new bottom, and divide, just like we did with the scientific notation problems. Top times top, 4.6 times 47.90. Stick it in your calculator. 4.6 times 47.90. You get 220.34 on top. On the bottom we have 1 times 1. Well, that's 1. And then when we divide, 220.34 divided by 1, well, anything divided by 1 is itself. So we're left with 220.34. Now let's talk about your answer. We need a unit and an element for our answer. And here's another shortcut we can add back to page 18. So let's go back to page 18 real quick. And let's add a couple more shortcuts to the bottom. What goes up must come down. Was a new shortcut we just learned. And you can only use each color exactly twice. You can only use each color exactly twice. So 2 new shortcuts, what goes up must come down, and you can use each color exactly twice. So knowing that, we already did what goes up must come down. That's how we got moles of titanium from the top down to the bottom. And if you can only use each color twice, well, I've already used moles twice. 1, 2. Moles are done. I've already used them twice. I only have one other color in this problem, yellow, grams. So I need to use it a second time. That second time is going to be in my answer. So I'm going to label my answer as grams. There's my second yellow. And what element? This is still titanium. So there's my answer. Now I know that many of you are like, I have no idea what just happened. Don't worry, we're going to do more of these. It's going to be fine. I promise. It's going to be fine. So, knowing it's going to be fine, let's look at problem 2. The very first thing we should do is color it. Do you see any words in problem 2 that have colors that go with them? Moles. What color is mole supposed to be? Moles are supposed to be green. So I'm going to color the moles green. And there's another word in here that needs a color, atoms. Atoms are supposed to be blue. I'm going to color the word atoms blue. Okay, so far, not so bad, right? We're just coloring. Coloring's easy. You've been doing coloring since you were like 3 years old. You can color. I have faith in you. Let's look at our steps again. Step 1, start with our given, a number, a unit, and an element over 1. So we look at this problem. They gave us a number right here, 4.5 times 10 to the 24th atoms of titanium. There's our number, unit, and element. So I have to start with that, rewrite it, number, unit, and element over 1. And again, color atoms. They're blue. Now, step 2 says figure out how many fractions and draw them. Well, you said earlier, if you see the word moles in the problem, that's going to be 2 fractions. I already have my first fraction. Here's my second one. That's not so bad. 2 fractions. 1, 2. Step 3, the unknown, which should be a unit and an element, goes on top of the last fraction. So I already used this blue here. My unknown is what they're asking me for, how many moles. That's my unknown. That's going to go on top of my last fraction, moles. And we're still using titanium in this problem, so it's going to be moles of titanium. And again, I'm going to color moles green. To fill in this bottom part of this last fraction, we have to remember one of our shortcuts, a new shortcut, which was the rule that what goes up must come down. What goes up, and that's just referring to words, unit and element, what goes up must come down. So atoms of titanium was on top, what goes up, atoms of titanium must come down to the bottom. And we always color atoms blue. Now, if we can get this far, then putting in a number should be relatively simple because we have shortcuts to figure out our numbers. Green is always 1 mole. So in front of moles here, I'm going to put a 1. Atoms are blue. When it's blue, we use 6.02. So I'm going to take that number, 6.02, times 10 to the 23rd. Again, that's called Avogadro's number, named after a dude, Avogadro. I'm going to take that number and write it in. Because when it's blue, you use 6.02. It rhymes. Now, when we have filled out all our fractions, we're ready to multiply and find our answer. I'm going to point out, even before we do the actual math, we should know what labeling we're going to give to our numerical answer. Because again, we had another shortcut that said we use each color exactly twice. Well, I already used blue twice, 1, 2. I need to use green a second time. I've used it once in this fraction, but I need it a second time. How about it goes in my answer? There's the second time I can use it. I've used atoms twice. Moles I only used once. I need to use it twice. And my answer also needs an element. We've been using titanium this whole problem, so it's going to be titanium. Now the math part just comes down to your calculator. Remember, we do top times top, bottom times bottom, and then divide. I'll point out that anything times 1 is itself, so we really end up doing 4.5 times 10 to the 24th over 6.02 times 10 to the 23rd. And when you put that in your calculator, make sure you use the E button. Go ahead and type it first, 4.5 E24 divided by 6.02 E23. Type it yourself, and then I'll show you what it should look like in your calculator if you type it correctly. Go ahead, type it yourself. 4.5 E24 divided by 6.02 E23. If you type it correctly in your calculator, it should look like this. And if it doesn't look like this, then you typed something wrong. You may have typed a times sign in here, or typed a times 10e or something, but it needs to look exactly like this. Remember, we round to the hundredths place, so 7.47, but this 5 here is going to round the 7 up to an 8. So instead of 7.47, I should end up writing 7.48 for my answer. Let's look at number 3. Again, first thing we're going to do is color. I love coloring. Been coloring since I was a small child. I'm so good at coloring, and I'm sure you are too. So what words do you see here that need colors? The word moles. What color does moles need? Moles is always going to be green. And grams needs a color. What color is grams? It's yellow, golden grams. Okay? Remember that if you see moles, you're going to need 2 fractions, and in this problem I do see the word moles. So I'm going to need 2 fractions, 1, 2. And just like before, that first fraction should be the given number unit element over 1. So here's the number they gave me, 105.2. That is a number of grams, and our element is still titanium. I'm going to put it over 1. And whatever they're asking me to find should go on top of my last fraction. So they say how many moles. They're asking me to find moles of titanium. So moles of titanium are going to go on top of the last fraction. That's the unknown that they're asking me to find. Goes on top of that last fraction. And to fill in this bottom section, again, we have this kind of shortcut rule here. What goes up must come down. If I have grams of titanium on top, grams of titanium must come down. What goes up must come down. My unit and my element should come down. Now to fill in the numbers for these, again, we have shortcuts for that. Green is always 1 mole. So I'm going to put 1 mole here. Yellow is always some number from the periodic table for grams. So I need the number from the periodic table for titanium, and fortunately, we've already got it on this same page, 47.90. That's my periodic table number of grams for titanium. So I'm going to put 47.90 right there. Before I go putting anything in my calculator, I can go ahead and recognize that when I get to my answer, I've already used grams twice. I can only use each color exactly twice. I've already used grams twice. So my other color, moles, the second time I use moles is going to have to be in my answer. There's my second green, one in the fraction, one in the answer. And my answer, we're still in this problem, still talking about titanium. So there's my two yellows, there's my two greens. This whole problem's been about titanium. And now we can go ahead and calculate. Remember, top times top, bottom times bottom. You'll get a new top and a new bottom, and then you'll divide. And again, I'll point out anything times 1 is itself. So you're really just doing 105.2 divided by 47.90. So type it in your calculator. Don't wait for me to write it on the board for you. Type it in your calculator. When you type it in your calculator, you get 2.1962 blah, 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 blah. We round to the hundredths place. This 6 is going to round up, make our 19 round up to a 20. So this should be 2.20 moles of titanium. Let's look at this next set of example. It says a chemist produced 11.9 grams of aluminum. How many moles of aluminum were produced? Again, we got a color code. Before we can do anything else, let's color code. What words do you see here that need colors? I see the word moles, should be green. Grams should be a color. What color are grams supposed to be? Yellow, golden grams. The number they gave me and its unit and its element go on top of a fraction over 1. And because I see the word moles, that tells me I only need 2 fractions, so I'm going to do times my second fraction. And I know what they're asking me to find, how many moles. That's going to go on top of my last fraction. So moles of aluminum goes on top of my last fraction. And I know what goes up must come down. So these grams of aluminum that are on top, they need to come down to the bottom. And to fill in the numbers that go here, again, we have a shortcut rule. Green is always 1 mole. Grams come from the periodic table. Now this is aluminum. Earlier we were using titanium, which is 47.90, but we've now switched elements. We're not using titanium anymore in this problem. So we have to actually go look at our periodic table, because this time we were less nice. And we didn't put the number for aluminum right there on the page for you. So we got to go find aluminum on the periodic table. And its number of grams is that 26.98 there. So that is my mass for aluminum, my molar mass, the number of grams that are in 1 mole. From there, I can realize I've used grams twice, yellow twice, done with yellow, done with grams. I need to use moles a second time. It's going to have to go in my answer. And to find my final answer, I multiply straight across, top times top, and get a new top. 11.9 times 1 is still going to be 11.9. Bottom times bottom, get a new bottom. 1 times 26.98, still going to be 26.98. If you divide those two numbers and round to the hundredths place, you're going to get 0.44 as your number of moles. And here's what we're going to do now. I'm going to go ahead and tell you that number 2's answer is 356.14 grams of aluminum. And I'm going to tell you that the answer to number 3 is, let me double check this before I write this down. Yeah, 1.66 times 10 to the 24th. I did not leave myself enough space. Atoms of aluminum. That's your answer to number 2 and your answer to number 3. What I want you to do now is show me the work, or really show Miss Woodlock the work. Okay, see if you can figure out how many fractions. Spoiler alert, they're both going to be 2 fractions. Fill in your 2 fractions, and then double check yourself in the calculator. See if you get these 2 numbers. After you do that, I'll go ahead and tell you right now, you're going to have some time to work on page 20. And if you go to your stamp page real fast, I will go ahead and tell you that your stamp for the day, which I believe today should be, again, depending on if it's an A day or a B day, either the 26th or the 27th, your stamp for the day is going to be completing page 20. There is one more video to watch today. Miss Woodlock's going to give you some time right now to work on page 20 and to also double check yourself for the bottom of page 19 here. And then you'll have another video to watch after she determines how much time it'll take. So, I'll see you on the next video.